welcome again for this webinar on robotics for high-risk fire and industrial operation. Today it's our sixth seminar, which will be with several speakers. First, we will have Martin Nekula from the Czech Republic Fire Service, also Vice President of the International Fire Association for Firefighter and Rescuer, CTIF, also involved in FEU, the Federation of European Fire Officers. We will have a second speaker, Ivana Krzyk-Korbayova from the German Rescue Robotics Center, and our presenter from Shark Robotic will be Bruno Cruchon, presenting the technology developed by Shark Robotic. My name is Olivier Salvi. I am the coordinator of the Direction project and also manager of Ineris development. So today we will have first the expression of the need, setting the scene about the need for robots, for new technology with a robot. This part will be presented by Martin. The second presentation will be about the state of the art, the research insight on robots for emergency response, and it will be presented by Ivana, and the industry perspective by Bruno at the last presentation of this webinar before the discussion. So I wanted to say that this webinar is organized in the framework of a cooperation under the Disaster Resilience Society Stakeholder Hub that is hosted by CMINE. And this is a place where projects share media production on a single place. And you can find the previous webinar on this place, but also webinar and as other media developed by a European funded project. Today it's organized by the Direction project, which is a disaster resilience knowledge network aiming at promoting innovation, technology uptake, and the cooperation between different stakeholders. In our project, we have identified some gaps. We have tried to identify the needs of responders, to screen and identify potential innovative solution. We also work on the creation of a co-development environment so that the innovations that are developed by industry meet the requirement and the expectation of the first responder and the rescuers. And we also promote any knowledge, any information about innovative technology, like today with the webinar, and this is part of our objectives. So I propose that we start now with the first presenter, Martin Nekula, who will tell us about the needs and the challenge faced by firefighters. So Martin, the floor is yours. Please turn on your microphone, please, Martin.
Is it better?
Yeah, now it's better.
Thank you. Hello, Olivier Bastien, dear colleagues, dear responders, providers. Firstly, I would like to say thank you for the opportunity to have a second possibility to present my ideas about robotic systems and drones. And the main reason of the participation in activity is possibility and also experience with fires and operations by fire rescue service and deployment of units, and also cooperation in development of using drones and robotic systems at the scene if fire rescue service is responsible for that incident as a leader of operation. How can robots improve effectivity of fire rescue service in the events of incident? That is the idea, how to provide that topic and also cooperate in Direction project, because Direction project is one of the most important parts for supporting development of technologies and also providers. And this is the reason why fire rescue service can be more effective in effectivity during the incidents if it needed. From my opinion of view is that drones in emergency operations can make our work more effective. The reason is that during that intervention, we need to do assessment and also have a ongoing monitoring of the situation, also have all information about fire and accident scale, presence of people, for example. And this is the reason why drones and robotic systems should be supporting us during these interventions. Everything is needed because we need to increase safety of the situation and also safety of responding units, also firefighters at the scene, but not only firefighters, also people who are affected by these situations. If I'm thinking about robotic systems, I have to say that robots are important for me from two reasons. If I'm thinking about robots, which are necessary to set up during interventions, I am sure that we need for our better idea and better working at the scene, have two different platforms of robotic systems. The first platform is small platform with possibility to have a real-time visual and data transmission, also possibility to see by the camera and also by thermal camera. And after that, use also the bigger brother, for example, robotic system, which is able to support that deployment of units by possibility to have a big nozzle to extinguish fire, also move obstacles, try to improve or support moving, for example, injured people and other tasks which are not able to provide by the small robotic systems. For us, it means that we try to do our work by clear operational and economic value. It means that we try to save the time, reduce damage by fire at the scene, also have a lower risk for firefighters, and also try to have a feedback from new data capabilities. It means that if there are data or some possibility of pictures, and we are able to accept these pictures, we are also accept to bring better understanding of the situation. We use drones during our interventions. It's standard this time, and I have to say that during the time we are trying to develop or improve our responsibility and cooperation with robots, it looks like very good because in many interventions we are able to better do coordination and the development of, for example, cooperation between drones and robotic systems. We try to set up autonomy of data system because we are aware about that it's danger if the system is open for sources. So we try to set up system which is covered by special system with accessibility only into our net and not possible to be possible to have an impact from outside to our net. So this is the reason why we are very aware about situation with dangerous can be caused if somebody is trying to reach the information and data we have in that time during intervention. Of course, we have to be able to challenge new possibility, have a special idea how to cooperate between drones and robotic systems, and have no only interview of that picture from the air, but also as people can see the situation around us. So every information is connected to one system and present to a commander and have a better idea of the situation. It brings some solutions, and also the most important are results of that we are flexible and resilient. We have robotic systems and drones which are also resilient, and it means that we have to better support all emergency situation and operation. Our current technology used by Fire Rescue Brigade of Moravia Silesian region is that we use 35 drone pilots with this equipment. We use also drones for training. We also use drones for intervention, and also cooperate different departments who are responsible for using. If somebody needs investigate situation at the fire or after the fire, they use special part of that. If we try to have a fast track or fast picture from the situation, we use a little bit different. If we need to have analysis into the buildings, we use also special construction of drone to be able to use these drones inside the buildings. What is the idea how to improve our situation now, because we are responsible now in the area of drones, but we are not able to support our intervention by robotic systems as robots who are able to move on the ground and bring the same idea and the same feedback as drones. Now we are thinking about the two platforms I mentioned before. It means that we would like to have a small one with camera survey, thermal camera, and the big one with possibility to transport material, extinguish fires, transport injured persons, or load some special equipment and try to push or pull obstacles. Beside that, there is necessary to have also the small one with possibility, for example, to load a bottle, as you can see on the right picture. I have few examples of that possibility how to improve or be better in deployment of units if you have robotic systems, because we had a few interventions last time when the situation could be supported by robotic system, but in only one occasion of that was that we used robot from colleagues from Slovakia to supporting the fire of Banzan, which I will have also in this presentation. But first idea how to present this opportunity is industrial fire, because we had a fire of hall with storage. There were 17 fire units. Also, that place was separated into three firefighting sections, and this is the main reason when we need the picture or the analyzing by drones. It means that it can bring you a better overview of that situation. What could be the contribution of robot? Of course, if we are able to explore these robots at the scene, we can be more successful in increasing the possibility of safety and security of that intervention. Also accept that unstable buildings can be dangerous for firefighters. Also have a possibility to move something without reaching the people in person. And these are the reasons why we would like to think about the robot is needed. Another one is the example of forest fire, when we had the 19 fire units involved, also drones at the scene, but we have no robotic system. And in this case, the robot can bring idea how to move nozzles, how to move hoses at the scene, and possible to continually extinguish the fires, also in cooperation with firefighters at the scene. When we use drones, we have a possibility to predict the situation, for example, with wind or some different possibility to have an idea about moving firefighters at the scene, also support people who don't know about situation, who are able to reach some place at the scene and be supported by drones. We know about that if we can use also robot, we can use that robots for transport of materials, search for hidden places by thermal cameras, also used for extinguishing of fires. That situation with a huge fire of benzene was supported also by drones, and also after our ask to colleagues from Slovakia, that was supported by Shark system from Slovakia, our colleagues, firefighters, and supported by these robots. Because there were 38 fire units and the situation was very dangerous, that was only one way how to continually check the temperature of the benzene in the tanks and be able to have a continual information about that situation. That was very important for us. That was reason we were able to support our firefighters by robotic systems. After that, beside the thermal camera inspection, we used that drones for overall monitoring of that situation, and robot which was at the scene we used for transport of material. That benefits are visible. There was a used firefighting robot to reduce risk for firefighters mainly. One example and a question for me and also for providers and producers of robotic systems is idea how to provide that deployment of units in connection not only with drones but also with connection between drones and robotic systems. Beside that, we had a huge fire in buildings. That was a complex of buildings. There were 28 fire units, and the problem of that was that we had to be able to cut the roof of the buildings, because under the roof was the fire spreading during that holes, and there was no possible to stop the fire and extinguish without that possibility. And the drone was supported that picture and imagination what happens or what can happen, and how was the effective to use units at the scene, and that was also cooperated with possibility of drones. Of course, we didn't have robots at the scene, and if we have a possible, if we had a possible to set up also robots, it could help extinguish fire in the middle of that place between buildings, because there was a huge temperature and that was not possible use nozzles in cooperation with firefighters. There was only possible to have monitors on the ground and extinguish fires in that place by these static monitors. Of course, robots could help this situation to increase the using water and foam in that place. The last exercise of using robots is one place when we have a continual fire of heap. That's a fire in a tailing heap from nearby coal mines. It means that the fire is underground, and on the surface there is a temperature 140 degrees. It means that it's possibility to have a fire in that place in every time. And this is the idea how to cooperate drones and robots at the one place if there will be possibility to have continuity of drone monitoring, and after that continuity in deploying robots in the ground, use them to extinguish fires if drones are able to inform you about the situation that fire is on that place or another place. Because it's a huge area, it's not possible to deploy fire rescue service in every time and have a continually checking of that place. This is the reason why can be deploying of drones and robots very successful also in this place when we use when we have to use firefighters because of fire. What is the possibility how to bring some new idea for us from providers or from developers? It seems that if we try to cooperate between providers which are able to support drones and also providers who are able to support robots, and we would like to find connection also with some feedback from firefighters. This is the idea how we can bring something new for fire rescue service, and this is the reason also for me in the Czech Republic how to bring something new. For example, for that place, for fires, for dangers of next fires, how to cover that situation, be able to have a overview of that situation, and after that extinguish fires by drones and robots in one place in one whole system. So thank you, Direction, for that possibility to develop that idea, and thank you very much for opportunity to have a presentation. Thank you.
Thank you very much, Martin, for your very informative presentation and by illustrating different operational situations where we see that robotic can be useful, and also your message to promote the cooperation between drones in the air and the robotics robots on the ground. So I think it's an interesting field of development as well. I would like to now invite Ivana to take the control and start her presentation about the situation regarding research on robots. So please, Ivana, tell us.
Thank you very much. Good afternoon. Ivana Kruijf from the German Rescue Robotics Center. Thank you very much for the invitation and the opportunity to talk to you here about who we are and my thoughts about what we are doing in research in disaster response robotics. I decided that I would talk about this topic that has been occupying me for some years now, and that is how and where research and first response practice meet, and how we can do this well so that we together advance disaster robotics as best as we can. I don't need to talk to you about the potential and actual value of disaster robotics or robots for disaster response to make a response more safe or more efficient, because Martin has just done a wonderful job in this. And I have here some animations that I need to click through. So thank you very much for that. And I can immediately go into where I come from and how I got into this area. Starting from software engineering background, I worked for many years in language processing and in dialogue systems, and this was long before large language models came to play a role. And then I worked in social human-robot interaction. I'm saying this because this background very much shapes still today the kind of issues that I am particularly interested in when it comes to disaster robotics, namely human-robot collaborations. How do the teams work? How does communication in the incident response team work? And how do robots fit into the operational structures? So altogether, together the big topic of human-robot teamwork in this area. I started working in robot-assisted disaster response in 2014 when I had the honor actually to take over the coordination of the project that was called NIFTY, and was really a groundbreaking project at that time, one of the first attempts in Europe to take robotics not just out into the open, but also into the complex, unstructured and dynamic environments as we know them from disaster response. That was at that time really something new, and some people thought like people were crazy to try and do that. And within that project, not only great progress was made on this, but even a real deployment, which is illustrated with the picture bottom left. Happened in Mirandola after an earthquake. NIFTY did experiments in several quite realistic scenarios, including a tunnel incident, a railway incident, and earthquake, and as I said already, the real deployment. And then the next project that we did in this area was called Trader, and it was focused on prolonged missions in industrial environments. And actually, the topic, Martin, that you talked about sharing information between drones and ground robots already came into being addressed to a certain extent in that project as well. On the robotic side, among other topics addressed at the robotic sites were quite for then advanced perception, autonomy, and as I mentioned, multi-robot collaboration, as well as speech processing, so controlling robot by speech commands, which at that time did not really fly that much, pun intended, because the autonomy just was not sufficient for that. Nowadays, we are somewhere else, and it becomes an issue again that would actually be interesting and potentially more useful. And I'll talk about what we are now doing in DRZ on top of that, and here and there mention our most current project called Karma. But before I go there, let me say this. On the basis on the basis of the experiences that we had in these projects, we realized that the central big question, big lesson that we learned, is the importance of working closely with end users. That we need to experiment early, we need to listen to end users, what they need, and we need to develop systems that address these needs. Back then, we called it user-centric design and development. Today, we call it co-design, or Olivier earlier said co-development. For us, it meant regular joint exercises and evaluations, typically in 6 months intervals, testing systems in the hands of end users, and developing mutual understanding and trust by doing this. And you see examples there from the various activities in these projects that we had. This is how closely we have and continue working with end users. And when I say trust, I mean and a mutual understanding. This also then meant that when it so in the videos. So in 2016, when another earthquake struck Italy, the Italian fire brigade, the Vigili del Fuoco, called upon Trader as a research project to do a one-day deployment in Amatrice, just 1 week after the earthquake happened, with the goal to create 3D maps of 2 partially collapsed churches. And this was in 2016. The data couldn't be created online as it can be created now. It had to be created afterwards, and it was actually used by the firefighters and by the Ministry of Culture to handle handle the situation. So this I consider really like a good example of how the collaboration can work, and that was also why, based on this experience, that good things come out of consequently bringing end users together with developers. We founded DRZ in 2018. I was involved from the start, and then I joined full time in 2023 to work on this mission. So we founded DRZ with the goal to unite first responders, researchers, and also industry partners and public institutions in order to together advance robotic systems that protect and use lives in hazardous environments. And so formally, DRZ is an association with members who contribute to its existence, and we consider this combination of research, industry, and end users really essential to what we are doing. And the goal for DRZ is to enable and facilitate and support the user-centric development that I've been talking about. We try to work in a supporting and facilitating way around this development cycle that starts with understanding the user requirements, testing systems in any phase of development in as realistic environments as possible that we can also set up in our living lab, indoor and outdoor, that we have in Dortmund. And when possible, we bring research, even research demonstrators or other systems into practical use, for example, through the robotics task force that we have together with the fire department of Dortmund. And then we also organize training for first responders, primarily to learn from experience of others, to build capacities to use robotic systems. And from all these activities, then it's a circle, right? So we bring it again into knowledge about what is needed, what is not yet solved, and to develop, to help developers elicit the development of further useful systems. So that's kind of the main activities of DRZ. And why do I believe that DRZ is extremely important to have? Because, and Martin's talk already showed some examples of that as well, because we have we have quite some innovative concepts as well as demonstrators available on the research side, and also on the development side in companies. And yet still not all that there is in practical use by first responders. And this can have various reasons. It's not always, I mean, not always every idea works, but it may also be that the fit for the operational constraints is not yet worked out, or not as it should be. Or it could be that the training is not available, or it could be that the systems are not doing exactly what they should be doing. And that's why we think our work is important to help bridge this gap, and that in both directions, that developers understand what end users need, and that end users get better idea of what there is. Now, talking a little bit about where we are nowadays, it's a big task, because disaster response robotics contains or envelopes many topics. But so, I mean, the pictures there show some of the demonstrator systems that we have at DRZ. Martin has already shown some many further examples. I just wanted to say, in first responder practice, and again, Martin's talk was perfect example of that, showing that drones are already becoming very common. I can just add that, for example, in Germany there are like 550 drone units. Now, the current practice is mostly that drones are used for live images in teleoperations. Some some partially autonomous missions, but yeah, much more is possible. When UGVs are concerned, again, Martin talked very nicely about the potential uses and some current uses, and clearly the interest is growing. If you're familiar with the technology adoption curve, then we are with the drones already in a kind of majority use, with UGVs more in the early adopters phase. I would say that in Europe, I think in the Netherlands, the situation is probably the most advanced, where they have several robotic units which deploy ground robots in regular deployment several times a week even. France is also doing quite well. I have just come from a Karma project pilot with the French fire brigade in Paris, and they have already also quite a bit experience and systems at different places. The current practice is mostly line of sight operation, and commonly actually at quite close distance, which is not quite the idea, right? Because we want to use robots so that first responders don't have to go into the operations. And I am somehow behind my time. But in research, there is much work on advanced operations beyond line of sight, distance teleoperation, and of course research, navigation. So even on some commercial systems, waypoint navigation is already emerging. Typically we have like optical and thermal cameras and human performed perception. And in research, all this is going direction autonomy, direction using AI for object and persons detection, and in the area of navigation, first experiments with also using radar in low visibility conditions. We just did it with Karma yesterday in Paris as just one example. So there is too much to do a thorough overview in such a short time, but I would like I would like to now actually get back to this issue of listening to customers, my kind of most core message that I want to bring across today, to listen to first responders. And here I'm actually borrowing a slogan from Amazon, who are really famous for their obsession with customers, and they talk about listening to customers while at the same time knowing your technology and having a vision, and bringing these three elements closely together. So I want to talk about some of the ways that we work with first responders. Starting very early on in the design phase, it's possible to use methods such as data sheet overviews, where you basically present the potential technology that is being developed and discuss the uses on that basis, or carrying out tabletop exercises as like we did early in the Karma project. Now this has some this is very useful for initial exploration, but because it's imaginary, there is a danger of being too idealistic on the one hand or too skeptical on another hand. So what is really needed are joint practical exercises where first responders can get hands-on experience in conditions which they are familiar with, and also from the other direction, that developers get exposed to operational conditions that are common in practice. So such practical exercises, also called field trials or pilots, the downside is that they are very resource extensive. You have to bring the people together, you have to bring the technology, you have to prepare the site. Very often the research prototypes are unstable, not yet robust enough, so you get delays, you get unpredictability in what can actually be done during the tests. Often in projects, integration and testing and debugging effort is underestimated, so this makes it worse. And sometimes there is also hesitance to let first responders operate such systems that are at the moment, that are still immature, and or may be a bit expensive if an end user who is not a very expert user does something unexpected. Therefore, training is needed, and also it's important to use safeguards and things like that anyway, always. But I would argue it is really worth this high investment in resources, because this is the only way to really get good, practical, useful feedback. In doing these kind of experiments, there are various ways in which end users and developers can work together. The most desirable modus of operation is that the first responders get hands-on experience with the technology. They are actively using it and actively experiencing it. That is, of course, best. One has to realize that for this, typically extensive training is needed, so that the first responders really become, some first novice users, but then their experience grows with every run. They need to know some theory and get practical hands-on experience. There is also a danger that when you run an experiment this way, that maybe some more advanced features do not get used, because the first responders are not yet that familiar with it. And so that's why sometimes it's good to do a combination where more experienced users are actually demonstrating the technology, or are kind of accompanying the active use by the first responders by advising them. So that's a little bit, when the first responders are just observing the use, then it's a more indirect experience, but it's still a good experience, but better experience than nothing, right? And when developer and another potential drawback of running it in such a way that first responders only observe is that the developers who are then operating the system are not familiar with the operational procedures, with the communication protocols, with the tactics, etc. So there is a danger that they do things in the mission that the first responder would actually not do. A possible mitigation is by training the expert technical personnel, such that they become a bit more familiar. And here we are again at this issue of building mutual understanding for how to work. And the third modus that I want to mention is the taskable support, or the original term coined by Robin Murphy, taskable agent, where the operation is really executed by experts, and the first responders only consume the outcomes, the data or the information that is produced. This is sometimes good also for development. Especially it's good, or it's okay, when the focus is on the higher level of command or decision making, because then you actually only need the data. I just wanted to make a note here that there are various, that in some cases we kind of have structures available to make such mixed teams work in practical deployments. I mentioned the DRZ Robotics Task Force, which is exactly such a setup, where researchers or advanced developers are working together with end users to bring cutting edge technology into practical use. And a similar possibility has been developed in Austria, where they have the so-called University Fire Brigade, which are researchers who are also trained firefighters, so they can then join such teams. And usually for experiments, it's best to have a mixed modi, depending on how mature a particular technology is, than to use the suitable modus of operation as possible. I have one last point, but I'm slightly aware of a potential lack of time. But let me mention it at least quickly. That one additional aspect that plays a role is, I called it here, operational freedom during an experiment. So there are experiments where actually the team follows a very detailed scripted demo, or well, the level of scriptedness may differ, but a scripted demo where there are predefined phases, predefined steps, and detailed sequences to be followed. So this in such the scenario may be completely known, or maybe there are some unknown aspects like location of victims of hazards. Such a scripted demo setup enables exact testing of technology use in predefined conditions and sequences, because then you know that the technology that's to be tested actually will be used because there is the script for it. On the other hand, we ran also many experiments in a much freer setting where we basically just gave the scenario, like the way that first responders do their exercises. We said, this is the situation that happened. Here is the technology. We have previously trained the first responders in using the technology so that they were aware of the possibilities. And their task was simply work on the problem. How would you go about solving it? So this is much more exploratory. It has the danger that, as I said, some technology may not be used because it just doesn't occur to apply it. But then again, it kind of really shows how systems would be used in a more exploratory fashion at the operational level. And these are kind of the experiences that I wanted to share, kind of the possible ways of working together between research and first responders in a very close fashion, and some of the considerations that one needs to have when planning such activities. So let me repeat once more that the current state of development is that robotics for first responders is progressing, and to a great degree already is available, but there is still adoption remains uneven, and there is room to do much more. The main challenge from my viewpoint is not only technical performance, but the operational fit. And I and some others really strongly believe that real progress requires early and sustained collaboration between developers and first responders, and that practical exercises are very demanding, but are essential if we want to make this progress. And let me close that, our organization, DRZ, exists exactly with the aim to make such collaboration structured, continuous, and productive, and we are always there to help if anybody wants to apply this kind of methodology in order to advance their research and development. So yeah, thank you for your attention, and I hope I was not too much long in presenting.
I think it was perfect in the sense that you managed to deliver your messages, and we have seen that there is a diversity of situation where robots can bring a lot of added value. We have seen as well that if you want to meet the expectation of the users of the emergency responder, you need to create this cooperation at an early stage, and that they need to get familiar with the system. And I hope also that during this moment you take a lot of feedback to further improve your technology as well. I thought also that your presentation with the training and the importance of training is very useful, because not only you need to train the people to use the techniques, but they should think about how they have to change their doctrine or their SOP, having this new system helping for their mission. So I think you manage well, Ivana. So I'm very happy with your presentation, and I hope the attendance as well.
Thank you very much. I'm looking forward to questions later.
Yeah, I remind that you can ask your question in the Q&A section of the tool for the webinar. And now I would like to invite Bruno Cruchon to turn on his camera and take the control for
Sure.
the presentation.
Hi. Yeah, I think I took the control.
Yeah.
Let's
You
give it a
did.
try. Okay, good. So thank you. Good afternoon, all. It's a pleasure and an honor to be there with you. It's of course difficult to talk after such experts as Mr. Nekula and Ivana, but I'll do my best building on the 10 years experience of Shark Robotics with this simple motto, saving lives through technology. I just want to tell that, well, I'm not going to elaborate on use cases because these have already been talked upon. I'm more going to focus my presentation on the way we try to bring useful innovations at scale to end users. And every word counts, useful, because you don't want like a robot that talks, that is completely autonomous, that is like a very intelligent machine. You want a robot that has actually added value on the ground. Innovations, because of course, to bring added value, you need to invent stuff. You need to have something that's different from what you could use before. And able to deliver at scale, well, because when end users order robots, if it is to be useful, supposedly the unit might need more than one. And scale brings also economies, and it's important for adoption to lower the cost of these machines, which for too long have been quite expensive, and we're working on that. So we are a French European company with a team of 85. We're all based in the west of France, and I do encourage you to come visit this region, which is so beautiful. That's where I'm from, by the sea, by the Atlantic Ocean. And most of our supply chain is European, the vast majority of it. And it's very important for us because we know we are working in a troubled geopolitical context, in a troubled supply chain context. And if we want to be able to deliver the robots we have been ordered by our different clients in time, it's important that we don't rely too much on faraway suppliers and also on geographies that don't share sometimes the same values long term than our countries in Europe do. Because as I'm going to mention, talking about Ukraine, etc., we see that more and more rescue services are part, say, of the global security continuum. So we are nearly 10 years old. We sell in more than 20 countries. We actually, fun fact, have more robots in Singapore than in France. It's always a quite shocking figure, but it also reflects the challenges of adoption. But this has taught us, through challenges and difficulties, this has taught us some high level of service in maintenance. We partner with local resellers to be as close to possible as to the end users. And so we design and manufacture everything ourselves. I mean, not all the pieces, of course, but like we order the pieces, we assemble. We have a software team, we have a mechatronics team. We do our own AI more and more to have the best possible integration of all the parts of the robots, whether material or immaterial. Next slide. How does this work? Hop là. Just trying to move. Attends. Voilà. Yeah. So last slide on who we are, but it also shows a lot of what we do with the end users. So we started, of course, with firefighting robotics, the main one, the Colossus, which some of you might have seen, might even use. We developed then a smaller one, like the little brother called the Rhino Protect. So the first one was designed through a partnership with the Paris Fire Brigade, who is still one of our main end user. Then in 2019, you might have heard of that intervention of the Colossus in Notre Dame, where during the fire at the cathedral, it was actually instrumental in containing the fire inside the building. Then we extended on dual-use stuff, on law enforcement, military, etc., etc. And I'll talk more about what we do in Ukraine with an upcoming joint venture there. So, yeah, the link between this slide and the previous one is that what you don't see on these slides is the robots we stopped making. Because, of course, over our 10 years history, we didn't build only 5 or 6 robots. We tried much more. Robots for CBRN threats, robots for petrol, oil and gas exploration, etc. But we decided like 3 years ago to be more efficient, to be more targeted. We kept only some platforms, and just to do them better and to lower the cost of those platforms. So hence, we are working in a modular logic. You know, you have one Colossus, but then each end user has different needs. So you can put, of course, the water cannon, the video turret, but you can also put the stretcher to evacuate wounded people. You can also put the breath as system to get into thick smoke. And we just invented a thing that I'm quite proud of, which is the railway kit. So it's an assembly of aluminium pieces that in less than 12 minutes is going to allow the robot, the Colossus that you saw, to go from a road to railway tracks. Hence, you're bringing firefighting capacity and also firefighters on trolleys, you know, at the deepest of tunnels. Because tunnels, if there's a fire that catch inside, they can crumble down within an hour if there's no strong intervention inside it. So you're losing the whole infrastructure. And of course, the firefighters take enormous risks. So to allow firefighting intervention, we invented this that will bring the robot long range. Because I'm gonna mention this. We changed the transmission system to military grade transmission system if that's needed, and you can go like 4 kilometers away inside the tunnel to bring water, foam, to bring back intelligence, etc., etc. This was developed to revert on the DRS intervention. This was developed actually with end users, the firefighters in Lyon, which is the second biggest city in France. And if you are interested, actually, please do reach out to the firefighters in Lyon, because I know that they are trying to gather momentum to build a case for innovation funding for them, not for us, of course. And they need letters of interest from fellow colleagues, not only in France also, but across Europe too. So I want to transmit that message for our partners in Lyon. What we do in Ukraine, well, it's pretty simple. We delivered on a French grant that was a diplomatic support from France to Ukraine. We delivered 40 Colossus. And when I said at the beginning that we are able to deliver robots at scale, well, we delivered those 40 Colossus in 5 months. And they are active every day across Ukraine, from Odessa to the front line. And so, of course, we're going sometimes into Ukraine. I went myself twice in the last 4 months to Ukraine for a week, and we met the firefighters there. And quite frequently, we see online, well, just as our other end users do, and they post the pictures online, but we are quite proud to see that they actually are used after the drone strikes, whether on residential areas or on oil and gas depot, on energy facilities. etc. So this is clearly an example of what I was saying just right at the beginning, that our collective innovation on rescue and security tech does support people whose life is at stake, not only firefighters, which was our core mission, but here, as a company, we are very proud of supporting actually the resiliency of the whole country at our, like doing our small part to do so. And now to continue building on that experience, we are working to set up a joint venture with one of the best Ukrainian robotics manufacturer to set up a center of excellence in Kiev or in the vicinity to do the maintenance of the robots for CESU, the Ukrainian fighters, to provide more services to those guys, and also to better innovate, to bring innovation on civil protection robotics at the Ukrainian pace, as people say. So last but not least, on the recent innovations, it's interesting for you to know that both the Colossus and the Rhino project have evolved over time. So basically you have a big one, but not so big. It can go in a van, etc., and a small one. But as is apparent in these figures, the small one is actually being beefed up a bit. While the Colossus, the very new one that's going to be commercialized from this summer, has accelerated too. So it can go now beyond 10 kilometers an hour. It's very agile with a suspended track system. And we put, at the request of Ukrainians, actually, we put military-grade transmissions, which is very convenient, for example, for you also, if you go at the deepest of an underground parking lot, then it's important that the transmission can go like at -3, So here I did a small slide because after some time in the company, I was a bit perplexed between the talks sometimes of engineers that dream, of this very multifaceted product that could do anything, and what end users actually think matters. So on the very last Colossus that is going to be commercialized very soon, we delivered some small innovations, or like stuff that looks small, but that actually together are a game changer because they make the robot more simple to use, more mobile and more autonomous. So you can adjust remotely the water valve. You have this long military transmission. We're starting to put some AI, not on the Colossus yet, but we're working on that in the lab, and then the Rhino, it's done now. I'll do that on the next slide. A very simple but tricky thing. We have now batteries that you can change on the spot, because your phone, when it's offloaded, when it's empty, you need to recharge it. So you don't really use it. It's not mobile. It's a mobile phone that's not mobile when it's being charged. Well, you can't do that, of course, for a robot. It's not what you wish for. So now we have an internal battery within the robot, which allows you during the operation, you just take the battery out, put a new in, and the robot is continuously working, even when the batteries are out, because we have this small battery inside that does the bridge. Suspended track system, better obstacle clearance, a thing that's not visible, but that's a game changer for maintenance and then for operational availability, that the motors are out of the box. They are very close to the track system, so it's much easier to maintain the robot. And the last thing, of course, sometimes robots perform bad during on the field, and you need just to take it out of the way. So the robot it's a big thing, so it was very difficult to tow it. So now we just had a Swiss motor, a very fine piece of Swiss engineering. It's a disengageable motor, so you just turn a small button and up, you can just pull yourself the robot very easily. And last slide, this same kind of innovation we brought to the little brother, which is also less expensive. Remotely operated valve so that you can control the flow of water, you can spare water, etc. Advanced internal data logging. So every 25 times per second, 25 times per second, the computer within the robot registers data points from tens of parts of the robots, and then it feeds into predictive maintenance. And after that, we're going to do the same, but with external sensors to build a model that will interact with the world and that will help the robot, or better, help the pilot to control the robot. And what was very important on that one was that we put a much stronger motor, so that here you have a small robot, quite cheap, that has actually the same capacities as the first generations of Colossus. And I was asked to tell you what was like the difficult nuts that we were trying to crack now. So I conclude on that. Wildfire robotics. We would very much like to be of use on wildfire. So recently we traveled to the south of France. I also held talks with Swedish end users, with Canadian end users. And well, I do understand why so far we don't see so many robots on wildfire, because it's very difficult. Terrain is difficult. Distances are difficult. We need some sort of autonomy off-road, which is something that even the best companies in the world have difficult mastering. So we're working on that. We're constantly trying to find where small improvements could be of use on this very important topic for end users and for the whole of society. Thank you. And that's the picture from Notre Dame. Thank you, guys.
Thank you very much, Bruno. It was very impressive to see the progress of the company addressing different challenges time after time, and now also this dual use somehow of robots, or the benefits of robot in different situation. Thank you very much. It has been very interesting, informative, useful. I would like now to invite the participant to ask question in the chat. I would like to invite also all presenter to turn on the camera, and I would like to ask my first question to Bruno specifically. Also, so you said you have customer in 25 countries. When you deliver the robot to your customer, how is it? Do you organize a training with the robot, with the Colossus, or with a Rhino? Is there a moment, sort of, so you train people to use the robot? Do you feel the fire service who will use your robot, they have already modified their operational procedure, or they are on the way to modify it because they have new resources, new technology? Can you tell us about this experience? And I will ask also the similar question to Ivana about this.
Yeah, it's a great question. It's actually something we're working upon, and where we know that there is a way to improve stuff. We do train people, of course, because you need to teach them how to use these machines. Nobody wants that an ill-trained personnel damages the machine or damages the environment. And it's made to be efficient. It's made to be used. So it's important. And we always have a significant training part. But these are also machines that are quite simple to use. But what we want to develop now is a sort of compendium of, say, good practices from our end users, perhaps not only to feed into the training of the individual pilots, but also to contribute to the reflection of the new end user on building the doctrine.
I see the point. That is, you need some kind of rules to well operate the robot in different contexts, because at the moment it's quite it's a lot of freedom still to use this technology. How do you do? How do you do, Ivana? Also for the training, when you organize the training, is this with people who have never used any robot and it's the first time, or you have your usual partners to do the training, to test the new technologies that your labs has developed? How it works for you in your institute?
This differs really in different projects, but so we have done the situation where basically we had new end users coming, joining an exercise, and even getting quite little training in terms of sort of like a half an hour hands-on, and then they started doing a mission in environments that were medium complexity. Then we usually would compensate it by some experienced operator sitting next to them and advising, and of course always having, because of those are exercises, having a safety guard near the robot with the button which you can turn the robot on if any really dangerous situation starts happening. So that's kind of one extreme, and I am perfectly aware that half an hour training is not enough. I'm actually curious how it is with Shark. I know from other robotics providers that kind of the standard is at least a week of training to get the basis. And then like to get really experience, it's even more.
Yeah.
Is that about the same?
This was a question. In fact, how much training is needed for end user? Maybe Bruno and maybe also Martin, you can tell us your own experience in Czech Republic. And but Bruno, how much time do you dedicate for the training of your client?
Well, I'd say it depends on the number of people and the number of robots that are involved. And for example, when we delivered the 40 robots to CESU, we invited the Ukrainians to come to La Rochelle, and we dedicated like 10 full days of learning, training, and discussion. But I've also known of cases of people that were already quite experienced, with this kind of machines, and we just had a single day or 36 hours, and that was it. And then you keep posted on how the robot is doing.
Yeah, so and also in research projects, then what very often happens is that we keep a core group of end users who continue with the project, so it creates a kind of focus group, and they are then getting more experienced. But yeah, the training aspect from experience is often similar to integration is often underestimated what it takes. And one more comment that I wanted to make is, so now we kind of answered it at the level of robot operators, but there is also the command level, right? So that's where the tactics and the operating procedures are of relevance, and there equally education or training needs to happen so that the commanders actually know how to use this technology. And that has also been experience where we saw that when we did joint exercises with fire brigades, then when something actually happened, they knew like, here we have a situation that we are having trouble dealing with our usual means. And they would contact us and say like, can you guys come and assist with what you have, bring in what you currently have in research demonstrators to help with a specific situation. So again, here this kind of already existing relationship helps to do something more advanced in a real deployment.
Yeah, if I could just step in after this, just to explain as to what like a big day we think it's enough because we've worked a lot and we still work a lot on facilitating the pilotability of the robot. We just changed, for example, the tablet, like the operating tablet. We put big buttons. We worked a lot on the menus, on the multi-screen stuff. It should be as intuitive as possible. We also work on building a bird's eye view of the robot, because we know, especially after long hours of operation, it can be very difficult to pilot the robot out of sight just with a first-person view. So just in a video game, you take 2 steps back, bird's eye view, and then it becomes much easier. So through this investment on pilotability, on what in France they call the man-machine interface, or perhaps we reduced actually the necessary time for training. And in saying this, I'll address also the other question that I saw in the chat. Most of our end users never told us, and they also refuse sometimes to have autonomous firefighting robots. What they want is teleoperation, but with support sometimes from semi-autonomy. So we are working on AI stuff like push me, follow me, or push a button, the robot will pass through the door, the robot will climb the stairs. Everything that can reduce the mental workload at 3 a.m. after 12 hours of intervention. So that's what we put the accent on, not on autonomy. Thank you.
Very interesting. Very interesting. Your comments on improving the operability and the ergonomics of the system to reduce the mental load. Very interesting. Martin, I would like to ask you as a officer, firefighter, how it works using the robot. Did you have a training when you use your first robot? How it works? Do you train on a continuous base personal firefighter in your staff? So were you involved in some co-development of robots? So please turn on your microphone and tell us your experience.
Yeah, thank you for that opportunity. I have to say that we have 2 ways how think about, because I'm still waiting for a first piece of robotic system. This is the reason why I'm active in direction, and I try to discuss about that. We have been working for a long time in testing different platforms, also with colleagues from Shark. I have to say that it brings new ideas. But for the testing, we use the same shift, the same guys, because we try to select and compare the exact parameters. And this is possible only if we use the same polygon, the same place, the same tasks. Because the robotic systems are a little bit different, we have to be able also to be operational and try to use that place for testing different platforms. After we will try to purchase the first one, or we will be able to use some of product in our units for some testing as a contract between us and company for a free, for a testing, for a time. We have to be able to train these people in 3 shifts, because in the Czech Republic, fire rescue services on professional level use 3 shifts system for firefighters. And this is the reason that in every shift there should be able to operate with that. So for me, it's necessary to train minimally 3 days, but 1 week is optimal for that, to have a responsibility for taking control of the robot for 3 shifts. I know about the situations when we did the same tasks, but robots behave differently. It was caused because of, for example, disconnection when we use the robot in buildings from concrete or iron. These are obstacles, and we have to be able to find the limits, because we can't use robots if we need about overloading the limits. We have to be able to understand that these robotic systems support safety and security at the scene, and be aware about dangers which can be caused by the under controlling of that system. So it's not about hours or days. This is about continually training of our guys and people who are responsible for that. We have many equipment, but we know about that we have to train continually during all year. Summer, winter, these are differences between behaving of many maintenance. So this is the reason why I'm thinking two ways now.
Thank you very much. Ivan, I want to react on what you said probably.
Yeah, yes, I wanted to confirm, and indeed there was this question about routine training, how much. So I know the teams in the Netherlands, they indeed have a defined amount of hours. Now, unfortunately, I don't remember the number, but they need to take part in regular trainings during the year and accumulate a certain given amount of hours of this routine training. And I know that they have like once a week a session. You don't have to be there every week, but you need to come every now and then. And they do kind of small exercises, simulated missions, just so that all the capabilities are exercised. So I think this indeed is a kind of best practice to have these routine trainings that that you need to accumulate a certain amount of hours of active use.
Thank you. We have several questions in the chat that appear. First, there was a demand to have a feedback on the use of robots during forest fire. Bruno, you mentioned it already with some challenges that are still in front of the developers, but probably you are thinking about having specific features of your robots for forest fire. I don't know if Ivana or you have also some experience with use of robot in case of forest fire. Who would like to react? So what are the main use? What kind of task can be given to the robots? How is the robot looking or finding his way? Maybe in if there is a lot of flame, if there is smoke.
I'd say the challenge for wildfires that we saw is more to find a window where the robot is of use between 4 or 6-wheeled big vehicles that anyway will pass in many places, and pedestrian firefighters we can also pass in many places, because having the robot going forward like it does in an urban setting is very difficult, because the robot has difficulty to keep the necessary mobility while pulling the water hose in a quite destructured, quite complicated landscape. It's not the same thing as in an urban setting. So this mix of I must have water or not, but it's better, and I must be mobile in a difficult environment makes the case still quite difficult for robotics in wildfires.
Thank you. I think it's very clear. We understand this challenge. We have another question on, or maybe Ivana, you want also to add something on the fire robots?
So I cannot report a specific already experience. When we worked on a project proposal, and there the fire brigade had the requirement or the wish to use robots for material and water transportation, say from a road closer to where it's needed for extinguishing. That's one thing. And something a bit different than forest fires, we did experiments in like vegetation fires, so like fire on a field, and there drones were extremely useful for hotspot identification afterwards. Well, actually, we also did similar experiments in like vegetation between houses and stuff like that. So after the fire was extinguished, still doing monitoring with drones for hotspots. And we did have experiences where hotspots were identified, where the firefighters already proclaimed the fire for extinguished, which would have then reignited after a while.
Okay, thank you for this experience. I have the last question in the chat, which is about regarding the detection of gas leak. Which platform do you believe holds more long-term potential, ground-based robots or drones? So the person is curious to hear your thought.
I think that depends on the environment, right?
I think so. Huh? I think it depends also where the leak take place. If it is rather at the ground level, or if it is in the atmosphere, and depend also density of the gas, probably, right? Where you could better detect any kind of concentration of dangerous gas. Yeah. Okay, I would like to ask a last question to Bruno and Ivana, and maybe also Martin. You have an opinion about, do you have user groups? So, for example, for Shark Robotics, do you have an annual meeting where different users, clients come in a place and exchange about their experience and give you some additional idea to develop your future robots? Or the same to you, Ivana, do you have your usual co-developers that you invite for some days every year or every second year, and you present the new advanced, the new features, the new technology development to get their feedback and get some inspiration for the next generation? Do you do that?
Well, we would need to do that, and we actually like for the first time last October we organized a partners day for our local partners, the resellers, so that they better understand the product, that they see who we are as a company and the improvements that we made over the years. But this actually gave us the idea to do the same for the end users. So we are working on identifying a location in France, probably in the south of France for the weather, where we could feature the new generation of Colossus before the end of the year.
Because we as a project connected with emergency responder all over Europe and beyond, we would be happy to help also to bring any interested firefighter organization or rescuer organization to bring at the same place in one day or a couple of days, and so that you have some demonstration and also some kind of testing. I think it might be as very useful for a company to get this feedback, and also very attractive for the organization like the one of Martin, who have not yet purchased, they have not launched their procurement to get robots, to have some better idea of what they really need. So I think we could support this kind of activity. Yeah.
Yeah, and I can only say, yeah, we don't have it yet, but it's something that is on our agenda to start doing. So yeah, we thought exactly of this kind of format would be useful. And also recently the Robot Response Alliance has been established, and there also is the idea to organize exactly such like experience exchange events at regular intervals where end users, companies, and research can meet and exchange experience and show new products, etc. So there are ideas on the table to do these things, and it's going to start.
Yeah, I think we need to help the market growing for this kind of technology. Yeah. Okay, so I think it's time to close this webinar. I would like to thank you very much for your participation, for the attendees, and also for the speaker. Thank you so much for sharing your experience, your knowledge, your concerns sometimes also. and everyone will be able to see the replay on the YouTube channel, where you have already several webinars that are available on the different innovative solutions that have been detected by the Direction project. Yes, hope to see you for the next webinar. Bye-bye. Thank you all.
Wonderful. Thank
Thank
you
you
so
very
much.
much for
Bye-bye.
the organization and invitation.
You're welcome.
Thank you.
Thank you. Bye.